It says x to the third, and then all of that is raised to the second. So I'm going to rewrite it. It is saying x to the third, and then all of that is raised to the second. There are two approaches for this, depending on how comfortable you are. If you are somebody who remember indices rules, there's a rule that says if you have, let us say, a raised to the x, and then all of that in a bracket raised to another power again, the final result is to multiply the powers. So you multiply the powers. Yeah. So that's one of the approach. So that means this could be equal to x raised to the third up there times a little 2 up there. And that would have given you x to the 6 is 1 mark. So that's one approach. But if you never wanted to do it like that, you could have done it the ordinary way. You could have said, what does the square mean? Well, we know that when you square something, it multiplies by itself. Therefore, x to the third could be multiplied by x to the third. And you would now say, oh, when you have the same base, you add their powers. See that? You're still going to end up with the same answer. So it's up to raise y raised to the 8, and you're dividing that by y raised to the negative
5.
Bear in mind that when you, just as though when you multiply, you add, the reverse of it is when you divide, you subtract. And we're talking about you're subtracting powers, right? You would have y to the 8. Because you're dividing, I'm going to change the color for that. Because you're dividing, it's going to be a minus. That's for the division. But there is a negative 5. That is the issue. So that little trick there, don't let them trick you in the exam. The minus is for the division, but there's a negative 5. So that is going to turn everything into a plus right here. So we're going to end up with y to the 8 plus 5, which is y to the 13. Still going, still under our number 2 type of question. So it says factorize. What we're factorizing here is xy minus y squared. We're factorizing that. Xy minus y squared. All right. And you wanna run the different types of factorization through your brains as you go. First level of factorization is to think about the highest common factor. Do I have anything that would classify as the highest common factor right now? What is common? And you're saying that y is common. So what you want to do is to isolate that common factor, open a bracket, and then you're going to divide that highest common factor in the terms. For example, xy, you divide that by y. You can see the y cancel, leaving the x. The y square, if you divide that by y, you could see that 1 and the y will cancel 1, leaving just y. So we have this, and you close. And all of these are 1 mark questions you could see. So y, open bracket, x minus y is the answer for that. And a lot of times when you do these, you want to quickly, you could double check in your brain, because if you do the quick distribution, you will see you'll get back the answer. So for 1 mark, that's what they're expecting you to do. Following on this, we have x squared minus y squared. So as long as you're revising, then you're going to say, oh, this is the difference of 2 squared. Whenever you're doing the difference of 2 squares, all you want to do is just to open 2 brackets, because you're going to put the square root of the terms. The square root of the terms. What is the square root of x squared? X. What is the square root of y squared? Y. And you replace the same things in the bracket. You can put a plus and a minus, or you want to put a minus, then a plus. It doesn't matter. The same answer. So let's look at this. This is a follow-up in it, the same question. So it says, hence. This word has a meaning. Now, if they said hence or otherwise, then you can do anything you want. But if they just said hence alone, they are suggesting that the answers you just retrieved, you have to use them. Hence would have meant that simplify. So they are saying, if you look at these 2 expressions, They are the ones that we just did. So in other words then, we are going to, let me rewrite this bigger. So we have xy minus y squared over x squared minus y squared. We just did these. So when they said hence simplify, hence, we suggest that go back for the answers you got for these. So for this, so I'm saying my thing here is this word I'm focusing on it. Hence. They said hence simplify. I am saying to you, when they use the word hence, they are saying that the answers you just got, go for them. That's what hence means. All right. Sometimes they may say hence or otherwise. When you see or otherwise, you can do anything you want. But if hence alone is there, you have to use back the same answers that you just used to help. Therefore, if you notice, I'm using back my first answer here for the top piece, and I'm going to use back my other answer for the bottom piece. Because if you look at the expressions, we did this already, and we just did this up top. So you actually have the answers for them already. So it's not like you're going to rework, all right? So you're going to just go back for the responses, put them down, and then now observe. And when you observe, you're going to realize that, oh, I'm seeing this could cancel with this down here. You're going to realize that. And that is why they would make the question like that, because they knew that something will be there for you to cancel. So this cancel that. So at the end of the day, what you're left with is y at the top over x plus y. I told you that the dimensions is in x. It's okay. No biggie. All right. Now, what you're going to do now is to read to see what it is they want you to do. All right. So when you're reading here, we realize that they're saying, given that the difference between the areas of the two rectangles is 64. So this is very crucial, right? Show that x squared minus 2x minus 35 is 0. So they are saying that, listen, given that the difference between the areas, no, this is where the working is. And when I said working, I'm not saying difficulty. All I'm saying is you need to understand what difference means. It means that you're going to subtract. But at the same time, you also need to understand that they're talking about the areas of the figure. These are rectangular figures. So the area of this is length times width. And the area of this one is also length times width. It comes at number 2 in the algebra section of your paper. Obviously, they want to see if you can do your expansion, but they're doing it in a creative way. So I'm going to try to do it here. So we're going to work out the rectangle M. We're going to work out the rectangle N. So let me say this is rectangle M, and we're going to work out the area for it. The area for it is the length times the width. So here, I'm just saying, here is the length. It's a binomial, so I'm going to put it in a bracket times the width. See that? So I'm working out the area for rectangle M. No big thing. Apply yourself to it, right? So let me push the screen up a little bit, just for the working. Can you see the length times the width? So let's find out what it is. Now it's up to you depending on how you work. I'm going to do it I would say, the simplest way possible. But if you can do other creative things to find your answer, fine. I'm working it for the person who understands the least right now. So you're going to distribute. So you're going to let the 3x multiply by the x minus 3. And you're going to let the positive 4 multiply by the x minus 3. That is the principle. You need to carry it out. For example, when the 3x multiply by the x, you'll get 3x to the second. This same 3x multiplied by the negative 3, you're going to get negative 9x. When this positive 4 multiplied by x, you'll get positive 4x. And when this positive 4 multiplied by the negative 3, you'll get negative 12. Then you want to simplify. But you only can simplify things, right, that are similar, that are alike. These are the only like terms we have, right? So that means I could write back my 3x squared, right? But when I put together a negative 9 and a positive 4, I'm going to get a negative 5 with an x and a minus 12 at the back. And this would have been my response in terms of the area of rectangle M. Rectangle M, the area is equal to that. So I could write it here, that it is equal to 3x squared minus 5x minus 12, right? So that is rectangle N. Now we need to find out what is the area of rectangle N, right? So I'm looking for the spacing. If you don't mind, I could do it beside this. So you know what? I could take back this off for spacing, since I have it down the bottom right there. And you just put a little line here just to separate the next one, so you could see, you know, some order to what we're doing. So I'm going to find out the area for rectangle N. Let's look at it. What is the length? Length and width. So you want to put x plus 2 times x minus 3. All right. So those are what we're going to be carrying on. The procedure remains the same. So everything on the left or from the bracket 1 must multiply by everything in bracket 2. You set it up like this. Take out this x, let it multiply by everything over there. Take out the plus 2, let it multiply by everything over there as well. Then you carry out your, what we call our distributive law. When x multiply by x, you're going to get x squared. When x multiply by negative 3, you'll get negative 3x. When 2 multiply by x, you'll get positive 2x. And when 2 multiply by negative 3, you'll get negative 6. At this time, you want to stop and say, what do I have in common? Let's take a look, right? What we have in common is negative 3x and positive 2x. Those are common terms, right? So here is what's going on now. Square minus x minus 6.
So all right. From the like term, right where the like term is.
Yeah, man. I was saying that negative 3x plus 2x will give you a negative 1x, but we don't write 1. So it's going to be negative x, right? It means negative 1x. So that expression here would have been the area. That's the expression for the area for n. No problem. So now you have those. See them there? You're going to use this to prove what they want here. Let me put this for you in a different color. You want to prove this. That's what they say. So now you're going to do what they said. Subtract them and let it equal to 64. So let us set it up for it to equal to 64 right now. All right, let's set it up for it to equal to 64. And we're talking about, and here is the little problem that we might have. Now, you are seeing the bigger one. M is bigger. Let us look. Everybody said that M is bigger, right? So we're going to have M minus N equals 64. So based on what they're saying, you want to put the area of M minus the area of N, and it should give you 64. Principle. Area. They said that, not us. So now you're going to execute based on your idea that you have. So you have 3x squared minus 5x minus n minus 12. This is for m. Here is the mathematical issue that you might have. When you put the minus sign here, you know what? Let me put a different color. So I'm going to put the minus sign here. Subtraction. That's what the question was. Please understand that you're going to have to put this in a bracket. And this is where a lot of people make the error. They did not put this back piece in a bracket. You see this minus sign, if you don't put it in a bracket, it's going to only affect the x squared. But it's not just to affect the x squared, it's to affect everything behind it. So be careful, right? So what we want to do, as you can see, let us simplify this now. Let's simplify. Let's simplify, man. Let's relax. Write back this. EJ, remember to let me know when you come back. Write back the front piece. You see this negative sign? It's going to distribute itself and change everybody on the inside. And that is why we wanted to make sure that you put the bracket so that it is sorted. Make sure, right? Make sure. So now, what you're going to have is a minus x squared, and then the minus x becomes positive x. The minus 6 becomes positive 6. Yes, man. And then that's equal to 64. Simplify on the left side. So on the left side, you want to bring the terms that are alike. So if you want me to do it, I could highlight them. What I could do, I could highlight them with a different mark. Like this is like this. I'm going to change the colors. This is like this one. Watch the color code. This is like this one. And naturally, it's going to be like this one when it come across. So I'm color coding the idea. So everything is going to be on the left side now, but I'm going to group the things that are alike. So there it is. I would have touched them for you to see what's going on. I could write them, not rushing the working note. Come back. Minus x squared minus 5x plus x minus 12 plus 6. And I'm going to say to the class that you would agree to me that this is going to come across. And when it come over, it's not going to be a positive anymore. It's going to be a minus 64. And then you're going to be left with 0. X squared negative 4x. And you put all of this together, the negative 12 plus 6 and the negative 64, you're going to get negative 70. And that is equal to 0. Bring in the thing that we want to prove closer. There it is. So they want us to take the idea that we have and show that it can equal to that. So when you observe, it's when they ask you to do that. They are not telling you that when you do it, you're going to see the answer same time. They are saying, can you manipulate your answer with a mathematical correctness? You are going to manipulate it to let it equal to what they had wanted. Can you? And as Leon said, when you look at what you have and what you want, you can divide everything by 2. Look, if we divide everything by 2, everything, then it's going to transform to that. So now we're going to do it. So we're going to say, divide this by 2, you're going to get x squared. You divide this by 2, you're going to get negative 2x. Divide this by 2, you're going to get negative 35. You divide 0 by 2, you're still getting 0. Hence, the proof, true or false.